Thank you, Sean. I appreciate the introduction and welcome everybody. I haven't talked at DEF CON in a couple of years, and this is actually it's been a couple months since I've talked for the ICS Village. I'm always appreciative that they keep inviting me back to talk about some of the things that I've been working on, and providing me with these opportunities. So I give back every chance that I get. If this is your first ICS Village, please start to get involved. Reach out to them for some of your research with some of the information. Volunteer to talk as well. We want to hear from all of you, and I really appreciate it. What I'm here to talk to you about today is scripts and tools to help your ICS InfoSec journey. And this is just going to be kind of a brief introduction to how to do some of the things, or at least how I approach automating some of my tasks and come up with some of the scripts that I use to pull information from devices, whether it's for security research, as I'll keep pointing over here, but ICS Village provided me with the Schneider Electric Modicon M221 program logic controller, or PLC, to do some of my research on. And so when I point down like that, that's what I'm talking about. But whenever I'm doing security research, or I'm going on site to do a security assessment for somebody, I try to automate things as much as possible. And a lot of times I find out that I'm doing it on the fly. And so when Tom asked me to give a talk, I couldn't think of any research that I was doing, but I thought about this, helping people understand how I approach some of my tool development and automating some of my processes. So that's what we're going to talk about. Who am I? I'm Don C. Weber, also known as Cutaway. I've been doing information security since 2002, when I got out of the Marine Corps and went back to school. I have been fortunate enough to work on a lot of great teams. I have a broad background in information security, forensic, incident response, penetration testing, security research, and right now I'm helping organizations within the industrial control arena to evaluate their programs, to understand, doing security assessments within their control environments, reviewing their information security programs to protect those environments as well. Some of the things that we're going to be talking about and actually building towards are some of the tools that I used during my assessments. And you can see those out at the Cutaway Security GitHub. You can see that listed here. I'll highlight it. More specifically, we'll at least look at one script from the CutSec tools, some of the things that I've developed to gather information. And that's my goal, is to help you, if you're just starting out, understanding the thought process for coming up with something that you can automate. If you want to do some asset discovery, that's one of the tools that we'll look at. If you're working in this arena and need to gather information about your assets, understanding the firmware of your devices, what version they're running, you can automate some of that information gathering and store that off and make that process repeatable. So that's what we're going to do. We're going to talk about some of the concepts around information gathering and developing a script out of it. We'll develop a script real quick. We'll talk about some device interactions. Not sure, it depends on how fast we'll go. We'll talk about network analysis, and then we'll look at one of the scripts from the CutSec tools. All right, I'm going to go pretty fast because I only have 25 minutes and we've got a lot of things to cover. So the first thing I want to do is I want to open up a terminal. I'm using Kali, as you can see here. It's a little bit older version, but it will do for what we're working on here. When I get onto a network, whether it's talking to converse with a specific devices management interface, or it's a device out in my client's environment, if I'm on the network, I need to understand how my network devices are configured. So I'm going to run the IP adder. As we can see, I actually want to take off. I want to remove that IP address. So let's go ahead and, I believe it's delete. Yeah. So I'm going to start my IP address, or my my analysis, without having an IP address on my interface. Okay, I've got two interfaces here. This is a virtual machine, so I've got my Ethernet 0, which is bridged with my host operating system. That would be connected possibly to the internet, and so I don't want to connect my clients networks to that. So I usually go with a USB interface as well, and that's what the ETH1 is. I've got a USB interface that's attached to this. It's not going to my regular operating system. I can't bridge it to another network. It can only operate on this network. So that's where I start. Then whenever I plug into a device, like the PLC that I have here, I have to understand what the management interface is looking for. I need to understand what subnet it's on. Now, I can go through the vendor documentation, and that is one way to discover it. Another way is to actually query the information, because our operators and our engineers, they can change the configuration of those devices, those management interfaces. So they might have done something to keep it from us. And that's what we're going to see here. So one of the things that I start with is when I connect to a device or to a subnet, I just start, actually the first thing I do, let's call that up real quick. The first thing I do is I start a Wireshark. Okay, and I just start sniffing on the network. Okay, and I'm connected directly to a device, so this isn't broadcasting anything. I might start it and stop it, see if that changes. If I was on a regular network, we would see things like address resolution protocol, ARP requests. We're going to see broadcasts, you know, if it's Ethernet, or if it's some type of industrial control protocol like BACnet, we're going to see multiple devices communicating over broadcast messages for that protocol. And so I would listen to that to see if I can glean information, understand the IP addresses and the types of devices that are out there. In this case, we don't have that. So we have to do that discovery ourselves. Let's go ahead and close that. In this case, what I want to do is I want to use ARP scan. I need to run it as an administrator. I'm going to run the ARP scan tool. I need to tell it which interface I want it to go out, which is ARP Ethernet 1. And then I want to tell it which subnet to look for. So I want to identify all of the devices, the endpoints. I need to ask them for their hardware interface for this subnet. Okay. And when I run this command, we can see that it's, it starts spitting out a warning because I don't have an IP address on my own interface. It tells me what my interface information about my interface is, but it also says that there were no responses to the ARP requests. So in other words, this tool sent a bunch of ARP requests for that subnet, but nothing returned. Well, that's because the device has been configured with a different subnet. When I run it with the 192.168.0 subnet, we can see that something responds. And in this case, this is the PLC. It's been assigned the 0.21 IP address. The hardware address for its interface is this right here. And then we can see the manufacturer for that interface as well. Okay. This is how I start my assessments. Now, as I mentioned, the process engineers, they didn't have to keep the default, so this looks like a default address, but they could have changed that. This very easily could be in 192.168.50 or .100, and doing this by hand is really slow. In other words, I wouldn't have been able to find that myself. And so I could click up and, I could tab up and keep doing this myself, but I want to automate this process. And the way we do that is, first we need to start by getting rid of some of that extra information. In other words, we had that warning message. We also had the information about our interface. We don't need all of that information. Okay, I've got all that documented now. So what I want to do is I want to leverage my terminal and some of the things that it is capable of. I want to redirect the warnings. And so the file handle 2, I can redirect that into dev null, which is like the trash can. I can also search for the lines that have the information that I expect. So I should have the information about the subnet. And if I change that to 0 and hit enter, now this is going to run. Notice I didn't get any warnings or any other information. I have nice clean output. If there's no information coming back, so like the 1, there's absolutely nothing coming back. So I know I have a nice clean output. Now, remember, I want to automate this. If I don't know the actual subnet, if I wasn't lucky with the first 2, then I want to come up with a way to enumerate through all of the subnets. And we do that by looping through things. And so this is just a command right here, leveraging a for loop. Okay, for I, and I is going to be our a variable that we keep information in, and we're going to keep a list of numbers for 0 through 5. Okay, and then we're going to leverage the $I and our shell. In this case, it's the ZSH. Our shell is going to replace every $I with a number. And this is just the syntax for enumerating through. So 0, 1, 2, 3, 4, 5. I could go up to 254 because that would be the max number of subnets. And that's what I want to do. But we're only going to do 5 here for speed. Okay. And then you can see we have our ARP scan here. And this is our ARP command that we just talked about. I include the echo here. The echo with the, so this is, we need a way to understand that our command is still running, okay? Because a lot of times if we don't have output, some of our output might not happen. And if we don't have something to display, then we might think that it's frozen when sometimes it just takes a lot of time to get a response. And as you can see here, I have nice clean output. I can redirect that into a file, and I've collected some good information about this environment. I've created a repeatable process. I can copy and paste this, the command, and I can keep this like in a text document like this. And that way I always ensure that I run this command the same way every time, okay? And that's great, but I still want to automate it a little bit further. I want to actually come up with some type of script. And so that's what we have here. So I've actually got a list. So if I look in I've already put everything in the ARP scan. So if I cat this out, we'll see that I've just created a script with the command line that we just had. We have to, it's best if we tell it which shell to go in. Our for loop here, so iterate through from 0 to 5. Our echo, this time we want to tell it specifically where our program is. We don't want to just put ARP scan or the ARP scan in our script, because now our script is going to check our path. If we have issues with our path, it's going to break our script, and so we don't want to do that. So really all I did was, when I was writing this, I just did a which ARP scan, which tells me which program, where the program is actually located, and I just put that in there. Now if we run this command, we have to make it executable, but if we run this command, now we can see that output, and that's not what I expected. What did I mess up here? That should have run correctly. Oops. Oh. I didn't include sudo in there, and we definitely don't want to include sudo in there. We want to run sudo, and that's failure is a great tool. And whenever I'm on site, whenever I'm doing research, there are a lot of times when I do this, I don't get the results back that I expected. Well, there could be a reason. Either I made a mistake in my script, made a mistake in my command line, or I forgot to run it as administrator. And we can see that here. I ran the script, everything went fine, but the error message, because I had sent the error message to dev null, I didn't see that result. Okay, so running with sudo, we can see that now we have output that we expect to find, and that's great. This is exactly what we want. Now we have a repeatable process. Okay, from there, I can just save that out. Actually, after this, I should go and store that in the Cutaway tool. So hopefully that's, I'll remember to do that after we're done here. From there, that's when I want to assign myself or my interface an address on this network. Remember, we don't have an address on this network. Let's go ahead and go back. I'm just going to scroll up so I run the command correctly. So let's add an IP address to our interface. So sudo IP adder, we want to be on the 0 subnet. So let's give ourselves a .2. And when we run the IP adder again, we can see now we have an address on there. And from there, we can start looking at that device, okay? And in this case, I want to understand the services that are running on there. For a PLC, I would expect that they have management interfaces, potentially on potentially a web server, usually an FTP server, but there's always some type of service running on there. And so what I'm going to do is I'm going to do an Nmap. We have to be careful with these devices because they're not like our Windows operating systems, our Linux operating systems. They don't handle unusual connections well, and Nmap does make unusual connections to see how the endpoint responds. So we're going to format our Nmap command to make it safe for the device. And we can see I do want to run it as an administrator, and that will help with the output. We want to don't ping the device, so don't worry about if it doesn't respond to pings. Don't resolve, so the -N is don't resolve both of the port numbers and the endpoints. The ST will be a full TCP handshake, and it will establish the connection and tear it down. Some devices, if you just do a SYN scan, they will hang, and nothing else can connect to that until it actually gets a teardown packet for that connection, and that could have a negative impact on the functionality of that device. Then we're going to look for a specific, we're not going to look for all top 1,000 ports. We're only going to look for something that for ports that are associated with some of the management interfaces we expect. We want to start this, and we might scale up, but let's start small. So let's go ahead and do a scan of this right now. And as you can see, it ran. We didn't need to throttle this. It went through and it searched all of those ports. And now we can see that it only has one service that's running. Okay, and this is actually, I like this. It doesn't have an FTP server on it to serve up the configuration files. The only real way to communicate with these types of devices, you actually have to use a Modbus, and it's proprietary Modbus that's associated with Modicon, and that is what allows the communication and configuration of the remote configuration and management of these devices. So it actually would have to click over to my Windows system and run that Schneider Electric software to interact with this. But certainly now we could start interacting with the Modbus on this device. I'm not going to get into that. You guys can go out and find some of that, learn how to interact with Modbus. Actually, I've got some videos that are out there on the SANS ICS concepts YouTube playlist. So if you go out to that, you can just search for SANS ICS concepts. You should it should come up with some of the videos. There's 3 videos on Modbus enumeration, analysis, and machine in the middle attacks. So you can go out there and check that out. What we want to do is, so now we want to talk about more scripting and information gathering. I wanted to, and I didn't realize how long I would have. I wanted to talk a lot more about some of the things that I do associated with information discovery with Wireshark. And let's go through that real quick. Let me see if I can open this up. I've gone out to the Control Things website, and you can go out there, and there's a repository in the CT samples, and you can download some PCAPs of different protocols, and that's what I've done. I've gone and downloaded the combined. I've looked in the combined folder, and I've downloaded the Plant 1 PCAP. And as you can see here, this is just a PCAP with a lot of different industrial controls. And what I can do here is I can search for things like Modbus traffic. Okay, and this will display this display filter will filter out all of the different things that you can find within this that are associated with the Modbus protocol. All right. And how I script this is I'll start my analysis here, and then I'll start doing things like searching on destination. So I will destination port. So I'll right click on destination port, and I'll say prepare as a filter and selected. And then I'll just search for everything that is destination port 502. And we can see that this finds all of the queries. So this is just the queries. The client, which is requesting information from a device, that I know that this is a good filter. And then I can go in and I can take this filter and I can automate some Tshark commands. And I can go back to I can go and locate the actual PCAP and run a command line. Oops. Let me copy it over one more time. I can run Tshark, which will go out, and now I can set up a filter that will search on Modbus, search just on the destination port 502, so just the request like we saw in Wireshark, and then I can tell it, hey, only spit out the two fields. I want the IP source and the IP destination, okay, and then sort that information and sort it so that you remove all of the extra occurrences and you only provide me with unique results. So that's the sort U. And as we can see here, we've got a Modbus client, which is a single server querying a whole bunch of different devices. And so this is how, and what I do is I take this command and I copy it out and I maintain this so that I can repeat this command. I don't have to look this up every single time. And while Modbus might be relatively easy, some of the other industrial protocols get a little bit more complex for the information gathering like this. And so this is just a valuable way to do that. I'll take all of this information and I'll take all of these techniques and I'll start to, excuse me, what I'll do is I will create scripts. So let's go ahead and I'm going to look in the Cutaway Security Tools, ICS. I've created some Discover Asset scripts. And if we look at this, let me make this a little bit bigger. We can see that I've taken Python and I've created a Python script that leverages a Python Modbus module. And I've configured it so that we'll iterate over any subnet that I provided. And that's what we have here. So we've got a range, which is a list of subnets. Okay. I've got some specific devices that I've gone out and pulled research from the internet and looked up their Modbus map. Actually, that's what I was showing you up here. Okay. So I went out. This is an example of a GE device. A D60 line distance relay. I've went out and gathered the instruction manual. I'll search the instruction manual for the Modbus map. And the Modbus map for these devices, if you interact with this GE device, you can pull things like the serial number, the manufacturer, the modification number, Ethernet MAC address. All of this information is stored in specific locations within the Modbus memory. And then you can go and take that information and generate a script. And as you can see, I've gone through and looked at the memory mappings of several of these GE devices. And I've come up with ways to query, get the GE firmware, and it will go out and retrieve that information and bring it back to me and print all of this information out. And I can redirect it into a file. And this is one of the ways that I assist some of my clients with doing asset discovery within their environment. I did all of this by doing this research, by interacting with the devices on the command line first, figuring out the important information to grab, doing additional research, and then finding ways to script this up so that it's a repeatable process. All right. And that's all I wanted to show you. Once again, I appreciate everybody coming out, and I hope that you have a great DEF CON experience, whether you're in person or you're remote. Have a great day. Be safe. Take care. And we will talk to everybody soon.